Happening today, select rivers and streams will be closed in Yellowstone National Park. Yellowstone officials say that Madison River, Firehole River, and Gibbon River will be closed today from 2 p.m. to sunrise.
In Yellowstone National Park, geologists say one of the park's famous geyser basins now has a new hot spring.
Footage released by the USGS, it shows the eruption blasting out of a thermal pool, sending water several feet into the air. A much larger hydrothermal explosion happened at the same time.
Yellowstone National Park is one of the most famous and closely monitored volcanic regions on Earth, but scientists have just uncovered something extraordinary lurking beneath its picturesque surface, a massive magma cap that could rewrite what we know about the park's volatile heart. Using advanced seismic imaging techniques and powerful computer models, a team of geoscientists from Rice University, the University of New Mexico, the University of Utah, and the University of Texas at Dallas discovered a sharp, volatile, rich layer of magma about 3.8 kilometers or 2.3 miles beneath Yellowstone's iconic geothermal features.
Scientists have collected new data, giving them a better picture of Yellowstone's underground plumbing. Right beneath the caldera from the last eruption sits the magma chamber. And it's fed by a plume of magma stretching down 465 miles.
At first glance, this might sound like the prelude to a Hollywood disaster, but researchers say this hidden cap is not a ticking time bomb. Instead, it acts like a lid, trapping heat and pressure while venting gases in a controlled way, and its very existence may be the reason Yellowstone hasn't erupted catastrophically in the last 640,000 years. For decades, scientists have known that Yellowstone sits atop one of the world's largest active volcanic systems. Its caldera, an immense bowl-shaped depression that stretches across Wyoming and parts of Idaho and Montana, is the scar left behind by the last massive eruption. That eruption was so powerful it blanketed large parts of North America in ash and altered global climates. Since then, Yellowstone has remained active but stable, marked by thousands of small earthquakes and spectacular hydrothermal features like Old Faithful and the Grand Prismatic Spring. But the exact structure of the magma reservoir beneath the park has been elusive. Conventional seismic methods provided rough outlines, but the details, especially the shape and composition of the upper boundary, remained murky. The new discovery changes that by using a 53,000-pound Vibroseas truck to generate low-frequency vibrations and deploying an advanced wave equation imaging technique, the team was able to create one of the clearest images yet of Yellowstone's subsurface. The cap they found isn't a solid lid, but a mixture of molten silicate rock, gases, and even supercritical water, a state of matter that behaves like both a liquid and a gas, forming when water is heated beyond 374 degrees Celsius. These materials are interwoven with porous rock, creating a dynamic, semi-permeable barrier. According to lead researcher Brandon Schmont, seeing such a strong reflector at that depth was a surprise. It tells us something physically distinct is happening there, a buildup of partially molten rock interspersed with gas bubbles. What makes this cap so important is its stabilizing effect. The Yellowstone system constantly produces heat and gas as magma slowly moves and evolves deep underground. If these pressures were allowed to build unchecked, the risk of explosive eruptions could increase. Instead, the cap seems to act as a pressure regulator. Gases like carbon dioxide and water vapor are able to escape gradually through cracks and channels, venting through the park's geysers, fumaroles, and hot springs. Schmont described the system as steady breathing, a process where bubbles rise and vent safely rather than accumulating dangerously. Co-author Chenglong Duan noted that this venting explains the park's rich hydrothermal activity. Yellowstone's steaming pools and boiling mud pots are more than tourist attractions. They're signs of a system relieving stress. It's also worth noting that this discovery builds on earlier findings that Yellowstone's magma reservoir is much larger than once thought. In 2022, researchers found evidence of significantly more molten material beneath the caldera, though most of it is stored in partially molten form rather than fully liquid magma. The new imaging reveals that the reservoir's top is not a simple uniform surface, but a complex layer that plays a critical role in how heat and gases move upward. It's a kind of natural safety valve, and understanding it could reshape how scientists monitor Yellowstone's hazards. Of course, hearing magma cap under a supervolcano is bound to raise eyebrows, but experts emphasize that this discovery is not a sign of imminent danger. The volatile rich layer does contain gas and melt, but below levels typically associated with eruptions. In fact, its stability may help prevent them. Although we detected a volatile rich layer, its bubble and melt contents are below the levels typically associated with imminent eruption, said Schmont. Instead, it looks like the system is efficiently venting gas through cracks and channels between mineral crystals. In other words, the magma is restless, but not reckless. That said, Yellowstone remains a place of extraordinary energy. The system produces thousands of small quakes each year, some big enough to rattle nerves, but too small to cause serious damage. Occasionally, hydrothermal explosions, steam-driven blasts that can toss rocks and scalding water do occur, like the one that recently damaged a boardwalk and startled visitors.
A hydrothermal explosion happens when extremely hot water trapped under the Earth's surface converts to steam. Since then, the basin has been closed to the public for hazard assessments.
These events remind scientists and the public that Yellowstone is alive, constantly reshaping itself underground. The magma cap discovery adds another layer of complexity to this picture. While the system seems stable now, it's still dynamic. Changes in gas release, new fractures, or even shifts in the regional stress field could alter the balance. This research also highlights the incredible technology now available to geoscientists. Seismic imaging has come a long way since the days of simple travel time models. Dwan's wave equation technique allowed the team to handle noisy, scattered data and reveal details previously hidden. They essentially created a three-dimensional X-ray of the park's interior, one of the clearest yet. Such tools are critical not just for understanding Yellowstone, but for studying volcanoes worldwide. Similar techniques are being applied to Italian supervolcanoes, Iceland's restless systems, and even subduction zone volcanoes in the Pacific. What does this mean for the public? For now, nothing changes about visiting Yellowstone. The park's landscapes are as stunning as ever, its geysers as mesmerizing. The discovery is a scientific breakthrough, not a red alert, but it does remind us of the tremendous power stored beneath our feet and the need for constant monitoring. Yellowstone's last major eruption was about 640,000 years ago. Smaller eruptions have occurred since, and the system will eventually erupt again. Whether in thousands or tens of thousands of years, no one knows. The magma cap's presence might make that wait longer, acting like a sturdy lid that keeps the pot from boiling over. Perhaps the most exciting part of this discovery is what it teaches us about Earth's processes. Volcanic systems are not simple ticking bombs. They are breathing, evolving structures. Gases rise, magma moves, heat escapes, and sometimes those dynamics create new safety mechanisms. Yellowstone's magma cap is one of them, a reminder that even in the most powerful places on Earth, there are balances and feedbacks at work. For scientists, this is a goldmine of information about magma chemistry, rock physics, and planetary behavior. For the rest of us, it's a fascinating glimpse into the hidden world that shapes the ground we walk on.